A car decelerates uniformly to rest. From an initial velocity v to a velocity v over 2, it covers a distance d. How much further does it travel before coming to rest? Let's choose an equation, velocities and distance to be involved, and let's choose this one to be considered, that the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times displacement. And notice that in general it's a vector equation and it should be considered in projection or in components onto some axis, and let direction in which this car is moving be positive. So for the first stage, when velocity changes from v to v over 2, according to this formula, it becomes the final velocity is v over 2 squared is equal to the initial velocity, it's v squared plus 2 times acceleration times displacement. Displacement is equal to plus d, because it is moving to the right in direction which is positive. So 2 times a times d, so that acceleration can be found to be used for the second stage. So v squared over 4 minus v squared is equal to 2ad, and negative 3 over 4 v squared is equal to 2ad, so negative 3 over 8 v squared over d is equal to a. And the same formula for the second stage. The final velocity is 0 because it stops. So 0 squared is equal to u squared. U is this, so v over 2 or v squared over 4 plus 2 times a. It's negative, so it becomes minus, and 2 over 8, it's 1 over 4, so 3 over 4 v squared over d, and times s, and its displacement for the second stage, and since it is moving in positive direction, it will be equal to the distance traveled. We can see that we can divide each term by v squared, and we can multiply by 4, so that 3s over d is equal to 1, hence s is d over 3. So displacement and distance is d over 3, so B is correct. And that's all for this question.